As you can see in this exercise, it's just like a mix between chapters 1 and 2, linear momentum or mechanical energy. As you can see on the figure, we have two objects, one of them spheres, one of them is named A, the other B. They said that A is released without initial speed or without initial velocity from point D. And the path is frictionless, so the mechanical energy will be conserved through the rolling down from point D to C to N. Let's start with the first question. Question number 1. Calculate the mechanical energy at A. Sure, here we want to calculate the mechanical energy of the system A, Earth, but in general, what is the mechanical energy at point A? So ME at A. Yeah, I'll try to provide about less than a minute, some seconds to get an answer from you. اللي عنده أي answer, please try to raise your hands أو inform me before giving an answer directly. بس حتى لأنه في أكيد رح يكون في علامات على answers. إذا رح أعطي بعد شيء 10 أو 20 seconds بالكثير لحتى الباقيين يفكروا فيها.
أنا عندي جواب.
أمير أوكي.
أنا كذا.
أنا كمان أستاذ.
سوري هون الميكانيكال انرجي of particle A at D. So just fix it. Mechanical energy at point D, not at A. It's the particle. The name of the particle is A. The position is D. راح نجرب بلش مع yes. Can you repeat again?
يعني I tell the answer.
Yes, you can start if you want. يلا رح بلش معك.
Okay. ال ME equal KE يعني mechanical energy kinetic plus potential. The kinetic is related to speed and the initial speed is 0.
Okay, so it's kinetic.
So no kinetic energy. No kinetic energy since it is 0.
Starting from
the potential energy MJH. The mass we have it 2 kilograms. J we have it 10, and the H is 0.45 meters.
Nice work. Great. mg times h. The answer will be 4.5 times 2, which is 9. Who can tell me what's the SI unit for mechanical energy?
كمان بجاوب أنا.
Give me the answer. رح كمل معك أول part. Yes. Yes, the SI unit will be
joules.
J.
Yes.
Thank you. If there is any question concerning part 1, inform me about that. Else, I'm going to write the second question, which is number 2. Part 2, deduce the speed of particle A when it reaches point N, and they gave us the name for that. It's V1A. So it's the first position for this particle A. Okay, also we'll provide some seconds for you before we start with this.
استاذ أنا.
يلا حاطين بس seconds, so we will move to your turn right now. Yes, just wait a little bit, please. So just reminding you that the initial speed of A, VA 0, we can call it, it's 0 meters per second initial speed. And now we want to find V1A. Let me call this one V0A. So here V0A And now it's V1A equal question mark. Is there any question concerning the part number 1? Okay, great. Yes, Danny, go on. Part 2.
أول شيء ME equal 0 لأنه frictionless.
Okay, we just know that we say the variation of the mechanical energy equals 0. Yes, so delta ME equals 0. And since it's frictionless path, and it's conservation of mechanical energy. Thank you, Danny, for the first point. Yes, go on.
يعني بتطلع ME لل ME لل D equal ME لل M.
Okay, so mechanical energy of point D equals to the mechanical energy at point N. Great. What's next?
PE plus KE equal PA plus KE.
Great. So let me just write here 9 joules. And here it's PE at point N plus KE at point N. And can you tell me which one of these PE or KE equals to 0?
PE. لا ولا واحد.
Yes, you're right for the first answer, not the second answer. There is a 0 term. At point N, no height.
لا فكرتك عم تحكي عن السي.
No, they are right now. At point N, no height, so it's 0. Then it will be equal to half mv square. And this speed, they call it V1A, just to be strict with the naming. Okay, and now we can just do little mathematics. So 9 times 2.
تطلع 3.
Okay, and the mass is 2 kilograms. And here V1A squared. So it's 18 over 2. 9. And finally, the radical equals 3 meters per second. Okay, I'll wait a little bit for you to check the answer. And if there is any question, inform me about that before we write the third question.
Good morning.
Good morning. Is there anyone who can find that parts 1 and 2 are hard? Just inform me about that. Concerning Aline, I'm going to repeat the given after a while, just waiting for them to finish copying.
Okay. أنا كمان بكتبهم تحت يلي كتبناهم المرة الماضية.
Yes, it's a new exercise. You can write them after the last part. Here it's better to just add for the mass small a, just telling that the mass here is for particle A. Since after a while we will be talking about another particle B and its motion. All right, can I move on to part 3? If there is any problem or you want me to wait a little more, just inform me before I go on. Now we move to question 3. In this question, they will introduce chapter 2, linear momentum. They said that this particle A started moving from rest at point D towards point N. And let me just inform you what will happen here. A reaches N and moves along the path NM. So it's going along this path to the right side with the velocity V1A that we just found, which is 3 meters per second. So it's just moving to the right side. Another object B, which is shown here, also it's considered as a particle, and the mass of B is 4 kilograms. It's twice the mass of A, moves along the horizontal path from M towards N. So B is moving just backwards with a speed of minus 1I. So V1B equals minus 1I. Just note that minus I refers to the direction, so it's moving backwards, and the speed is 1 meters per second. Similarly here for V1A, we can just write it plus 3I, and the SI unit will be meters per second. So the value will tell us if it's the algebraic value, or the minus sign will tell us if its direction is negative or positive. Now we will reach collision. We call it head-on collision. The first question determines the linear momentum of the system. But can we expect first if particle A will go backwards, if it will continue to the right side? Is there any expectations for particles A and B, what will happen after collision? Or we can just go on with the exercise and wait for the results to appear?
Yes, so we do the exercise.
It's better.
Yes.
In such cases, it's hard for us to just expect. But usually, once we see head-on collision, particles moving face to face, expect that there will be just reflections of the speeds. So if it's going in 3I, it will be negative I, and B is moving to the left, then it will be moving to the right. So just expect that there will be like change of direction.
Yes, but we don't know. We can't know the speed.
Yes, we can't expect the values. Let's write the given for part 3 and the question. So you can just write with me part 3. So A, or particle A, reaches N and another particle B, we need an O here, another particle B given MB equals 4 kilograms, moves along the horizontal path from M toward N with V1B Okay, so here we'll call this one as V1B, and these will be the names for the velocities before collision. Minus 1I. And sure, we need a vector for V and a vector for I.
استاذ الكولاجين
Yes.
الاستيك او لا؟
Yes, sure. Okay, let me keep the size smaller. It's better for the shape. Now we'll write part number 1, part A, sorry. So it's 3A
أستاذ هني الهايت للدي عطينا إياها given.
Yes, on the figure you can see the value of the height here, 0.45 meters.
بس ال VA نحن كيف عرفنا إنه هي زيرو؟
As you can see here, they said that A is released without initial velocity.
أوكي.
Okay, part 3A. Determine.
بس استاذ تنزل لبارت 3 ما انا قلته كله.
I'm just writing it right now, yes. Determine the linear momentum P S, and here S is for the system. The system A B before collision. I'm going to solve this part since it's somehow new for us, although we might know the formula, but I'll do this part. And here they wrote PS with a vector, so we must find PS, P of the system, in a vector form, not in a magnitude. If they want us to find it in a magnitude, we'll just get rid of the vectors. Okay, I'll wait 10 seconds, then I will answer this part.
أستاذ بس can you repeat شو قلت؟ I'm
Yes,
كنت عم نحط vectors.
if they ask you to determine the linear momentum PS as a vector, then you must find PS as a vector, not find the magnitude of it. That's the point
Yes.
only. Okay. Let me start writing the answer. I guess that you're ready. PS vector, which is the linear momentum for the system, they didn't say that the object or these two objects are stuck together. Here we are just working before collision. So we have two different objects. Yes, Kamal, do you have an answer or a question?
استاذ انا حليت ال V1 برايم و V2 برايم طلعوا معي اجوبه. بدك اعطيك اياها؟
Yes, let me just take your answer.
اوكي V1 برايم -7/3
-7/3. Okay.
و V2 برايم 5/3.
5/3. By the way, كمال لسه بلش يشتغل لقدام، يعني هو سبقنا فات حط الكونزرفيشن في مومنتوم بتصور وحل وجاب الفيلوسيتي افتر كوليجن. Great.
هيك عملت.
We'll check the answers after a while. بس نحن بعد ما وصلنا لهذا البارت ما كتبت السؤال حتى. So in part 3A, to find the linear momentum of these two particles before collision, then we can just write PS equal M of A V1 of A plus M of B V1 of B, and I'm writing these in a vector form. The masses are given. A is 2 kilograms and B is 4 kilograms multiplied by V1A. V1A, it's moving to the right side with I direction, so it's 3I, and B, it's moving in the back direction with a velocity of -1I. So this one is a 3I positive, and the other one is negative. Okay, this is not plus, it's times. Now we can just write 6I minus 4I, and the answer will be 2I. This is the linear momentum of the system before collision. Check if you have any question or if there is something not clear here with this part before I solve.
بس استاذ سؤال.
Yes, tell me.
لما قالوا لنا reaches determine the linear momentum of the system. ما كنا لازم نعمل هيدي ورا هيدي السلايد اللي كتبناها على الامتحان.
They didn't ask us to find the velocities after collision. If they ask us to find the velocities after collision, then yes, you want to go to the slide that you are talking about.
Okay.
Okay, حلا السؤال أو I can go on, yes? If there is a question, let me know. Perfect. Let me just repeat what we did from the initial part till now. For those who just entered, simply, we said that we have here two particles, particle A and particle B. Initially, particle B is moving backwards to the left direction along this direction, while A is just rolling downwards along this path. A reaches point N with a speed of 3 meters per second. We calculated the value of the V1A at point N at this point by the conservation of mechanical energy, since there is no friction along this path. So friction equals to 0, then mechanical energy is conserved. Along the path from N to point M, collision happened between particles A and B. We calculated right now the linear momentum for the system of the particles A and B before collision. We just added M times V for A plus M times V for B. And now we'll check the next question. If you have any hidden parts, something not clear, please inform me. Let me just write part B. Okay, in question number B, determine the velocity Vg of the center of inertia G of the system AB. So determine the velocity Vg. Sure, this is also a vector of the center of inertia or center of gravity G of the system AB. I'm going also to do this part. Once they ask us about the velocity Vg of the center of gravity, we can just take into consideration a similar exercise for the man and the boat. So here we must assume that these two particles are one system object. So we don't write MA alone and MB alone and VA alone and VB alone. No, we just write the sum of the masses. How can we start with this? P of the system is conserved, which is equal to P of the center of gravity. Here we must assume that the linear momentum is conserved isolated system. And as you can see, the collision that will happen, it's going to be elastic. In order, right? Yes? Yes, Danny.
كيف بنعرف إذا السيستم isolated؟
Okay, usually to prove that the system is isolated, we must start from sum of F external equal, let's say, what are the forces acting on any of the particles we have here, the mass mg, the weight mg, plus the normal. If we are talking about the particle A, for example, and the sum of these forces will be 0. Then sum of F external equals to dp by dt, which equals to 0. Then P is constant, or P as a vector, it's constant. So now we can say that linear momentum is conserved. That's the way how we can prove it always and always, that the system is isolated and the linear momentum is conserved. Let's go backwards. So to find P of the system G, now we must write the sum of the masses of A and B. P of the system, we calculated this value previously, it's 2i. So 2i equals to 2 plus 4 is 6. Let me just write it along two lines, not with a single line. So it's here I, which is 1 over 3i. And the answer will be 0.33. Check this, please. If you have any question, let me know. So simply here we calculated the velocity. Yes, it's just the same rule. We are just working with the same rule, but changing. Sometimes we add the masses if they are talking about the system. Sometimes we keep the masses separated if we are just finding the linear momentum for the whole system without assuming it as a single system or single body.
بس مثلا ال PS equal PG determine the velocity VG. بس VG كيف عرفنا انه بنجيبها من ال PS equal PG؟
كيف عرفنا انه هاي بتساوي هاي؟ Is this a question? How can we know that PS equals to PG? Since the linear momentum is conserved, so P will be equal constant always and always. Okay, so since P is conserved or linear momentum is conserved, so P of the system equals to PG equals to P1 initially before collision equals to P finally after collision.
اصل الجي هي ال
Center of gravity of the system, not of one particle, of both particles. يعني إذا نحاول نفهم الفكرة بعد أكتر شوي، لكيف فيكم تاخذوا الأيديا منها. Look here, please. We can assume that particle A, which is going to this direction with the speed of 3i. And particle B is moving to the left direction with a speed of 1i or minus 1i direction. Now, if I want to check, or if I want to ask you, what is the speed of both particles as a center of gravity of one system? Then if we just take a look for both particles, assuming that they are one system, you can just go and tell me that the speed of the center of gravity of both particles is 0.33i. So the whole system is just as if it's moving to the right side as a whole system. So if you are on a ship, then the VG will be 0.33, then the whole system will be moving to the right side with a speed of 0.33. This is the assumption from a big screen, if you want, as if you are just zooming out from the screen and looking to the whole system.
يعني لأنه سرعة ال A أكتر.
Usually the highest, the particle with the biggest mass and the biggest speed will just control the situation. That's the case here. VA is 3, which is triple the speed of B. It will control the situation, although VB or the mass of B is twice, but the speed here is triple. That's the point.
بس يعني كانت B رايحة to the left side صارت رايحة على right side.
هسه بدنا نشوف بعد الكالكوليشن قديش صارت السبيد إذا راحت على right side بأي speed. Yes.
Okay.
Yes. Let's check within the last seconds or minute the next part, which is here we reached part 3b. Let's write part 4 here, which is the case of number 4. Now after collision, A rebounds. They told us that A rebounds and attains a maximum height HC. I will show this on the screen on the figure exactly. Here, let's start the part. Okay, and the question here, determine the mechanical energy of A, particle A, just after collision. Let's check what happened in this part. They said that after collision between A and B, particle A rebounds back, reaching point C with the highest height attained during this path. So at point C, we can just say that the speed of this particle is 0 right now. It's the highest point. The question they asked, what is the mechanical energy of this particle at point C? How can we calculate the mechanical energy at point C? Is there any idea? Do you have an idea about that?
No friction, mechanical energy is conserved.
Perfect. Perfect. Great.
وهي شو اسمه speed zero يعني راحت لسpeed zero potential. We don't look at the
So we just have the height.
Energy. We look
Yes.
at the potential.
Great. But as you know here, they provided us with the height HC. Let me check if I wrote it here somewhere. Yes, I have to write here maximum height HC equals,
It's half of HD.
I will write it here, 0.27 meters. So now, as Rayan said, we can just say mechanical energy of particle C, but at point
هي
C,
given الهايت للسير.
yes, that's right. So it's kinetic energy at C plus potential energy at C.
والفي صارت 0.
That's great. So 0 plus mg hc, and here mass of A which is equal to 2 times 10 times 0.27 equals to 5.4 joules. Nice work till now. Yes? Do you have a question? We still have
زيرو
لا صارت
زيرو الكي اي.
اوكي لانه هون